Hello, my name is Orlando Castilleja. Today I'm gonna guide you through a new tutorial to show you how to use SolidWorks. In this time, we're gonna model a nozzle, and inside this nozzle there's a sphere, and we want to find the characteristics of this flowing stream because of the presence of the reduction and the sphere. The main objectives are to generate 3D objects using different features loaded in SolidWorks. These features are extruded boss base, lofted boss base, and revolved boss base. We also want to show you how to specify parameters and boundary conditions, and we want to create a mesh for the resultant geometry. Finally, we want to display the results in different ways. The main problem is to find the characteristics of a flowing stream in a nozzle, knowing that a sphere is located in the space between the higher diameter pipe and the reduction zone. The fluids we want to analyze are oxygen. In this case, we only will show how the system behaves under the presence of oxygen, but you can repeat the exercise using water, kerosene, nitrogen, and ethylene glycol. The inlet velocity in the case of oxygen is 2.5 meters per second. In this case, we want to estimate the average velocity at the outlet. We want to display the velocity flow field and the pressure contours or distribution within the fluid. We also want to depict the pressure at the surface of the sphere and also at the surface of the duct. In this slide, I am showing the main features of the geometry. We will get an object like the one presented on the right section of this slide. And finally, we will get an animation like this one, where we are representing the velocity flow field, and every color represents a value for the velocity in this case. Okay, now I'm gonna move on to the SolidWorks window, and as you know, we're gonna select in the first window a new part. Okay, I'm gonna position on the right plane. I'm gonna select here right plane, and I'm gonna click on sketch. I'm gonna edit this sketch, and I'm going to select a circle. I'm gonna draw a circle, and I'm gonna select in the sketch menu, I'm gonna select a smart dimension. The diameter of this circle is 10 millimeters. And I'm going to the features menu, and I'm gonna extrude boss base function. I'm gonna select the thin feature in order for the cylinder to be hollow, and in this case I'm gonna specify 1 millimeter in thickness. Okay, just make sure that the inner diameter of this cylinder is 10 millimeters. In this case, I can activate this function, reverse direction. As you see, the outer diameter changes to the value of 10 millimeters, and if I click again, the inner diameter has a value of 10 millimeters. Okay, I'm gonna click OK. Then I need to add a new plane. I'm gonna select this face, and I'm going to the features ribbon, and I'm gonna select reference geometry. In this case, I'm gonna select again plane. This plane displays a value of 10 millimeters away from the reference plane I selected, and that's okay. I'm gonna click OK. I'm gonna draw again a circle, and it's gonna be a sketch on that plane, plane 1, and the diameter of that circle will be 5 millimeters. Okay, I'm gonna extrude again. I'm going to features ribbon, and I'm gonna select extruded boss base. I'm gonna activate the thin feature, and the thickness is already defined, 1 millimeter. Okay, that's okay, and I'm gonna click OK. Now we're gonna define the reduction here, and to do that I'm gonna select in the features menu, I'm gonna select lofted boss base. In this case I'm gonna click the edges for the inner circle, in this case this one and this one, and I'm gonna locate the thin feature, and I'm gonna activate the checkbox. Okay, as you see we have a thickness of 1 millimeter, and I'm gonna click OK. I just have to verify or check something. To do this, I'm going to activate the section view. Okay, and what I want to see is that the connection between those elements is done correctly, because sometimes we have some material that is excellent here, but I can see that it's okay. We don't have an excellent material here. Okay, but as you can see in this side we have an excellent material. If you wish, maybe you could proceed with the operation, as the simulation will be obtained only inside the inner domain, the domain of the fluid. However, if you like, we can do something else. For example, we can do something else to smooth this excellent material. To do this, we're going back to the loft thin 1 operation. I'm going to click on it, and I'm going to select edit feature. In this section, start and constraints, I'm going to expand this tab, and start constraint from the list, I'm going to select tangency to face, and in the part end constraint in the list, I'm going to select tangency to face again. Okay, I'm going to click OK, and now we can see that this excellent material is already gone. Again, in the inner part, everything is okay, and we're going to proceed with the sketch. Now we gotta create a sphere in the inside of this nozzle. To do that, I'm gonna create a sketch here over this face. I'm gonna select this face, and I'm going to select sketch. I'm gonna depart from center point arc. I'm gonna start from the center of the sketch. Okay, in that way, and I'm gonna close the semicircle with a line. Okay, with the smart dimension, I'm gonna define that the radius of this circle is 2.5 millimeters. Okay, you can see that the semicircle is sketched over this face or this plane, and I'm going to features ribbon, and I'm going to select revolve boss base. In the axis of revolution, I'm going to select this line and click OK. Now I have this sphere, but it's necessary to move it 10 millimeters away from the original place. To do this, I'm going here to the menu bars, and I'm gonna go to Insert Menu, Features, and Move Copy option. The bodies to move or copy will be only the sphere, and the displacement will be 10 millimeters. I'm gonna click OK. Okay, the sphere is already located where we want it, and our geometry is already done. We just need to go to the Flow Simulation, ribbon. If you don't have activated, you can go here to Options, Add-ins, and you look for the Flow Simulation. To activate the add-in, you check this box, and if you want it to be activated every time you start up your software, you can also activate this checkbox. Now, to proceed with the wizard, we need to create the leads. For the wizard to be able to determine what's the best computational domain for the simulation. To do that, I'm going to Tools and Create Leads. I'm going to select this face and this face and click OK. And that's it. We have now created our geometry of the nozzle, and I'm going to follow the wizard in this part. I'm going to type nozzle in the project name, next, and in this part you can change if you liked the unit system, and here you can determine you can type the number of decimals you want to show in your, or to display in your results. I'm going to click next, and the type of analysis is internal, and you can also specify, for example, the gravity acceleration. In this case, I can change here, for example, for the C component to 0, and I'm gonna type here 9.81. Okay, everything else is okay, and I'm gonna select next. In this part, we must select the fluid or the fluid we want to work with. In this case, you remember that our first option is oxygen, 2.5 millimeters per second, and I'm gonna look for oxygen. In this case, I expand the gases list, and I'm gonna select oxygen. Okay, that's it. I'm gonna select next and next. In this part, you can type or determine the thermodynamic parameters that are taken for reference, for example, temperature and pressure, and I'm going to click on Finish. Okay, as you can see, the computational domain has already been highlighted here. And if you want to hide that square or the domain, we can go here to the left side of our window, right click on the computational domain node and click hide. Okay, there you have. To show it again, do the same, right click on computational domain and click show. Okay. Now it's time to specify the boundary conditions. we go to the boundary condition node and right click on it and select insert boundary condition. Okay, here you have an option to select the boundary you want to work with. For example, if you click directly on it, maybe it's not a good idea because the software won't recognize that part as a boundary. As you can see, you have the 3D geometry you created with SolidWorks, but you also have the computational domain. In this part, you have a simulation and you need to select the real boundary within the computational domain. Then, to select the real boundary within the computational domain, you have to locate here in this part of your geometry, right click on it and select other. To select other, we must select this one, lead 2, that is our lead for the nozzle. Okay, that's okay. And what we have is the value for inlet velocity. Then we know that the inlet velocity is 2.5. Okay. Okay. We have a value of 2.5 meters per second. If you know that at this time the flow is already fully developed, okay, you can activate this checkbox. If you don't know, or if you know that it's not fully developed, then you deactivate it. I'm gonna leave it that way and I'm gonna click OK. The other boundary condition we know is that that the outlet is open to atmospheric pressure. To specify this condition, we also right click on boundary conditions, insert boundary condition, and we go here to the type zone and select this part, pressure openings. And the first option is environment pressure. The thermodynamic parameters specified by default is 1 atmosphere for the pressure and 293.2 Kelvin for temperature. Okay, the selection part, we must do the same that in the previous boundary, and we select other. Right click, select other, and select face lead 1. Okay, there you have. Right, excuse me, you have to click on OK. Okay. The mesh, we need to, well, if we don't specify the mesh, the software generates a mesh by default. But if you wanna see what is happening with the mesh, you can go to global mesh and you can create a, well, I'm gonna show the basic mesh here, and you can get a coarser or a finer mesh. Obviously a finer mesh is better, or most of the times is better for our calculations, but you must know that the computational resources must be higher. I'm gonna leave it in a level for 5. I think it's okay, and I'm gonna click OK. There you have. If you don't want to see the mesh in the geometry, you can right click on global mesh and hide basic mesh. Okay, I think that is already fully defined. And to run the simulation, we go here to the flow simulation ribbon and click on run. We click run. Okay, solver is finished. We close this window, and I'm gonna do something before starting to generate the graphics we need. I'm gonna go to display, and in transparency option I'm gonna select this one, and I'm gonna set the value for transparency to 100%. In this way we will be able to see what is happening inside the computational domain and the geometry. The first question we had is to know what is the average velocity at the outlet. We knew, or we specified, an inlet velocity for 2.5 meters per second, but we want to know what is the velocity at the outlet. Okay, then we go to this part, and I'm gonna position on this part of the window, and I'm gonna select surface parameters. Right click on it and insert. Okay, in this part for selection I'm gonna position the mouse on the lead 1, right click on it and select other. I'm gonna select lead 1, and what I want to know is the velocity. I'm gonna check the box for velocity and click on show. And here you have the value, or the average value for velocity, that is 10.007 meters per second. You have the minimum velocity expected at this phase and the maximum value for velocity that it will be pressure on the center of this of this geometry, or of the area. Okay, I'm gonna click OK. You can also change the name here for this definition. For example, I'm gonna type outlet velocity. The second part of the problem, it says that we want to know the velocity flow field. To generate an animation for the velocity flow field, we're gonna follow these steps. I'm gonna go here to flow trajectories, and I'm gonna click on insert. I'm gonna select, I'm gonna clear the selections, and I'm gonna select delete 2, lead number 2. I'm gonna generate 100 elements, and the elements will be arrows, and we can select here the variable we want to show in this profile. The problem says that is velocity, but you can select any property you want to show. It will be velocity. Okay, I'm gonna click OK, and there you have. This is a static image or graphic, but you can make you can have this image to move. To do that, I'm gonna position on flow trajectories. I'm gonna right click on this node, and I'm gonna click on play. As you notice, the lower values for velocity are in a cold color, and the higher values for velocity in a warm color. As you can see also in the zones near the sphere, the velocity is a little bit lower than in the bulk fluid. That also happens on the walls of the domain. Okay. We want to know how to show the pressure distribution within the fluid. I'm gonna hide this one. Stop and hide. Okay, to do that, to know the pressure distribution within the fluid, I'm gonna go to cut plot and insert. Here it's already selected the front plane. That is okay for us for what we need to do, but if you would like to change the plane, you can go here in this part of the window and open this tab and select any other available plane or plane that you have generated. Front plane, it's okay, and I'm gonna select in the contour section. I'm gonna click on pressure, and here you can change the number of contours you want to show. For example, that part. And okay, if you want to change the lining, you go to display and click lining. Okay, here you have a higher pressure at the inlet and a lower pressure at the outlet, and you can also notice that here there's some a change here behind the sphere. If you want to change what is represented in this plot, you go here to pressure and change the variable. For example, you can select temperature if you had a heat exchange problem, or in this part we can select velocity. Okay, here we know that the velocity is lower behind the sphere, and also after the sphere and near the walls of the nozzle. The fourth part is to show the pressure at the surface of the sphere, and also to show the pressure at the surface of the duct. I'm gonna hide this operation, and I'm gonna select surface plot. I'm gonna right click on it, and to select the surface of the sphere, I'm gonna try to do this. I'm gonna right click on here on the computational domain, select other. Okay, I'm not able to do this from here. I'm gonna cancel this operation. I'm gonna select plane. I think this one is okay, and I'm gonna go back to surface plots, insert, and from this part I can do it. I just what I did is I'm hiding just part of the domain in order to be able to get inside the nozzle and select the surface of the sphere. I'm gonna select, if you can see this, I'm gonna go back to display, well I'm gonna do it this way. I'm gonna select this part, and the contours gonna be pressure. If you want a higher number of contours, you can select more here, 50, and click OK. Okay, there you have. I'm gonna deactivate the section view, and here you have the pressure at the surface of the sphere. If you want it to be more smoother, the change in the colors, you can go back to the surface plot 1, edit the definition, and select a higher number of contours. For example, 100. There you have. Okay, you have a profile for the pressure on the surface of the sphere. Okay, we want to do the same, but now on the surface of the nozzle. Well, specifically the inner walls. To do that, I'm going to repeat the surface plot, insert, and I'm going to select the inner walls. Okay, I'm going to cancel this operation. I'm going to go to display, transparency, okay. Okay, I'm gonna do it again. Surface plots, insert, and well, I'm gonna activate section view. Okay, and I'm gonna go back surface plots, insert, and I'm gonna select these walls, the inner walls. It will be this one, and this one. And on those surface, the inner surface, we want to draw contours for the pressure. I'm gonna leave this value 100, and I'm gonna click OK. There you have. I'm gonna deactivate the section view, and I'm gonna set the transparency again to 100. Maybe the lighting can also be changed. Okay, there you have. And as you notice, we have contours for both the surface of the sphere and the surface of the nozzle. Both plots are shown over the same color table and are showing the pressure. I expect that this tutorial is useful for you, and I will be happy to respond any of your questions. See you later. The geometry I showed you before, it can be generated in many different ways, and maybe you can find a simpler way to create it. And now I'm gonna show you a little different methodology to create it. Let's go to the software, SolidWorks. I'm gonna create a new part. And remember that we will use the same measures. I'm gonna position on the front plane. I'm gonna click on sketch, and maybe it could be useful to generate the center line, a construction line. I'm gonna draw a construction line here. I'm gonna select it, and I'm gonna select infinite length. Okay, I'm going to create the line, a line. Okay, I'm gonna depart from the center. I'm gonna create something like this. Okay, I'm gonna select this line and I'm gonna specify that is a construction line. Also this one, and select that is for construction. I'm gonna select on the sketch menu the smart dimension and gonna specify that the distance between these lines is 5 millimeters, and the distance for this one, well, I'm gonna select first one, this is 10 millimeters. The distance in this section is 10 millimeters. Okay, I'm gonna undo. For this one, 10 millimeters, and for this one, 10 millimeters. Okay, the distance here is 2.5. Okay, I'm gonna click close dialog, and I'm gonna go to features and select revolve boss base. It says that the geometry is open. I'm gonna click no, and the axis of revolution, I'm gonna select the construction line. And the theme feature, I'm gonna specify 0.5 millimeter. Okay, and as you see, we will obtain something like we are looking for. Okay, I'm gonna activate this button. In this way, I make sure that the inner diameter of the pipes are the ones that we are specifying. This one, the radius of the higher diameter pipe is 5, and the another one is 2.5. Okay, here we have. Then to generate the sphere between the higher diameter pipe and the contraction, we need to specify a plane. Maybe we go to reference geometry, select plane. I'm gonna select this one as a reference, and I'm gonna specify that this plane is generated on the other side. I'm gonna select flip offset, and that's it. Okay, it's 10 millimeters away from the reference plane. I'm gonna click OK, and I'm gonna select this plane in sketch. Okay, I'm gonna select this function, center point arc. I'm gonna start from here. I select a point here. Well, it can be this way, and I'm gonna close it with a line. There you go. I'm gonna click OK, and I'm gonna go to features and revolve boss base. Here you have a sphere. Oh, okay, I forgot to specify the radius, but we can do it still. We go to revolve 1 operation, we select the sketch 2 and select edit sketch. In this case, I go to smart dimension, and I'm going to specify the radius of the sphere, that is 2.5 millimeter. Okay, select close dialog, exit sketch, and there you go. Okay, remember that you have to go to the flow simulation and select tools to create the leads. Select this face and select this other face, click OK, and you have the leads. Okay, and then you can go to the wizard and create the flow simulation model. See you later.